Welcome back to the second lesson about the tree data structure. In this lesson, we'll look at how to answer exam questions about trees. We'll also make sure that we're using the terms correctly and understand tree operations. Now, you remember things I've said before, often the very first things that we learn about a new topic are going to be extremely useful in the exam. I would say up to 80% of the marks will be for these early basic concepts. So make sure you've got these right. Supposing we have to say what a tree is. Well, it's a non-linear data structure. It's made of nodes. The nodes contain data plus pointers, and the pointers join the nodes together to make what we might call a hierarchical structure, a structure that is on levels. And make sure you're aware of the technical terms root, leaf, parent, and child, because they might use those in questions. If you're not sure about the meaning of those, go back to the previous presentation. Don't call things binary trees unless you're certain they are binary trees. They do use other types of tree in the exam, and sometimes I think they try and trick you or trip you up. So have a careful look at a tree and only call it a binary tree if no node has more than 2 pointers. If even one of the nodes has got 3 pointers coming off it, then it's not a binary tree. There are various things we can do with trees, and the three most basic are to add new data to the tree. So make the tree bigger by adding an extra node, deleting a single node from the tree, or traversing the tree. And remember that when we traverse a data structure, we visit every node in the data structure. And what we do then, that can vary. But for now, we'll just make sure that we visit each one. When we add a node, we have to do 3 steps. We've got to make the node at a free location in our computer's memory. Then we have to find a place where we can add the node to the tree. For example, a node that has got some spare space where where at least one of the pointers hasn't been used yet, so it's got room to add on a new node. With some kind of trees, there are even stricter rules about where you can add data. We'll come to that later. And then finally, we've got to add a pointer to link the parent node to the child node. So it's more work than adding an item to a linked list or a queue or whatever. Similarly, deleting a node is more work. We've got to find the node that we want to delete, and we've got to remove the pointer to that node. So far, so familiar. But be aware, if that node has got other nodes hanging off it, if we're not careful, we'll lose all of those child nodes. So we've got to somehow hook them back on to the tree. And again, there are a number of different ways of doing that, and we're going to look at some of those. But that's the basic idea. And finally, when we traverse any data structure, we have to visit every data item, and we've got to visit them once only. Now that's easy if they're in a line, you just go down the line. But with a tree shape, it's much more difficult, and there's actually more than one route that you can take through the tree to visit every item in the tree. And that's another presentation. But just for now, be aware that that's what traversing a tree means. And so that was a very quick presentation. You can go back and read through it again. And there's Tree Test 2, which is an online test. So have a go at that now. And when everybody's handed in Tree Test 2, we'll go on to the third in this series, which is about implementing a tree in a 2D array.